Hello, everyone. It's a real pleasure to be here, and I would like to present you the implementation of life cycle assessment in the policy decision process. You know that the planet is slowly, that we have passed some planetary boundaries, some tipping point for some of the environmental impacts, being biodiversity, biochemical flows, and others. And if we look at one specific sector, for instance, the Swiss real estate sector, and that we look at these different environmental impacts here, greenhouse gas emissions, biodiversity, water footprint, air pollution, eutrophication, you see that the environmental impact are located in different stages. Some of them are mainly in the use phase, for instance, the greenhouse gas emissions, or in the production of the building materials. But some others are really in the very early stage in the extraction of the raw materials. So to understand the environmental impact, it's absolutely fundamental to look at the various environmental impacts and to look at them during all the supply chain. The method that is usually recognized as the life cycle assessment. It all started with energy and with a very fundamental question from the Coca-Cola company that wanted to know if, from an energy perspective, it was better to wrap their or to bottle their product in glass bottle or in plastic bottle. And because we measure what we care about, they wanted to look at the energy along all the life cycle, so from the extraction of the materials to the end of life. Don't want to tell you what is the result of that, but what is sure is that since the 70s, the method has been expanded. So it worked first in a packaging aspect with plastic and looking at the energy aspect. And then it moved to materials, emissions, and especially chemical products with the involvement of the CETAC. And it arrived in the 90s with the first comprehensive method done by the University of Leiden. And then since 15 years, it's an ISO standard 14040, 14044. So as I told you, we're measuring what we care about, but then we also care about what we measure. And I would like to show you a few examples of problems related with that, which means that if the indicator is not well chosen, we might take wrong decision. I will illustrate that on for the energy and for the resources. For the energy, you know that we have energy efficiency strategy for reduction of the energy consumption in buildings, and that, well, it's not bad, but somehow it also diverges from the real environmental concern, which is the climate change. And there's recent studies that have showed the divergence between a zero carbon building, which is what we would aim for, and a zero energy building, which is what we measure and what the regulation is implementing. And of course, the divergence is much higher if you have a low intensity carbon intensity in your grid than if you have a high carbon intensity. So it means that focusing on reduction of energy demand does not necessarily lead to reduction of contribution to climate change. Another example done by Alina Galimshina, where she looked at robust renovation scenarios in Switzerland, looking at the environmental impact and also the life cycle cost. And she compared the existing building and the deep renovation, so the classic solution, the deep renovation strategy. And she showed that you have other scenarios, such as this one, which are lower from a life cycle assessment perspective, which are lower from a life cycle cost. They are also much lower from an investment perspective than the deep renovation strategy. And in this scenario, we just replace the heating systems and not so much deep investment in the facade renovation, which of course lead to extra embodied in the materials. So it shows that the most robust renovation solution for cost and climate change would mainly target the change of energy carrier and a minimum renovation in the facade, which are very different than the recommended and subsidized solution where energy reduction is the main target. Another example in resources, sometimes we measure what we care about, resource consumption, But the results don't really show what we think. And the main example, for instance, is the sand. You know that, well, we consume a lot of sand and gravel. This is the average consumption. But if you look at the environmental impact, the depletion of resources, then suddenly you see that sand is not depleted. What is driving the depletion of resources is mainly fossil consumption. Of course, you could distinguish between fossil depletion and non-fossil materials depletion, but then if you look at the depletion of non-fossil material, it's not the sand that is like the concrete, it's not the sand that is driving, it's the metals. So why? Because the environmental impact is looking at the depletion of resources. So does it mean that we don't have depletion of sand, we don't have problem? Or does it just mean that the indicator is not appropriate to what we want to measure? We have developed, or Dimitra Ioannidou in her PhD has developed an indicator for resources, which was not looking so much at the depletion, but at the pressure to access the resources. So the fact that if you have, in a specific territory, if you have a large amount of cities, either in quantity or also in the ratio between the surface of the quarry and the surface of the city, it will be more difficult to extract a resource because you have a question of not in my backyard principle. So NIMBY effect. And so we looked at this indicator of pressure to access the resource, pressure driven by the growth of the cities. And we show that effectively, you have, if you look at in France, you have territory where you have a pressure on resource accessibility. You have other territory where you have no pressure on resource accessibility. And if we compare France and Switzerland, what was interesting is that you see these indicators, and if we're ranking every small territory, every small department within the French and Switzerland, we show the same trends. We show certs that the shape, that you have some region here which have a very high pressure on access to resources, and you have others where there's a low pressure. And also we show that the surface competition between cities and quarries are governed by scaling laws, similar to Urban's Pro laws. So it means that the indicators we use for resource depletion are not showing what we care about, just because the appropriate indicators would be to use those related with local land use pressure. So we could add this indicator, of course, but you know that if we add more indicators to grasp really what we care about, with more indicators, it also reduces our ability to take decision. Let's just take a quick example on the Environmental Product Declaration. In Europe, the Environmental Product Declaration is based on 13 core environmental indicators plus 6 other additional indicators. But this is not enough. This is not enough to really grasp what we care about. So we have added a few indicators describing the resources, others describing the waste categories, and describing the output flows, like the possibility of reuse, the possibility of recycling, etc., etc., etc. So we have now 36 indicators. Who believes that with 36 indicators you can take a decision? It is not possible. So you need to reduce the number of indicators. And also maybe to focus, rather than measuring the environmental impact, to measure also how far we are from a political decision. This is the ecological scarcity method that is developed and used in Switzerland, where we don't necessarily measure the environmental impact, but we measure the divergence between the environmental impact and what we have decided as a political decision. For instance, for the nuclear power, Switzerland wants to go out of nuclear power. So as soon as you're using within the life cycle of your product a little bit of nuclear power, nuclear electricity, you will diverge drastically from your political objective, and so you would have a high ecological scarcity. On the contrary, if you take France, which doesn't want to get rid of nuclear power, then you would have no difference between, you would not have a difference in your ecological scarcity if you use a nuclear power electricity. And so at the end, in Switzerland, we have just 3 indicators, which allows certain decisions, because we have one indicator on climate change measured in CO2 equivalent, because that's the real immediate threat. We have one indicator on energy, not because that's an environmental indicator, but because that is the driving cost in terms of social and economic aspects related with the environmental impact. And finally, we have an indicator, the ecological scarcity measured in UBP, which is a way to align the production with the political ambition. And so at the end, it's not the role of the life cycle assessment to direct political decision, but it's rather we need to have a societal consensus about the ambition. And then the LCA is the tool to make the decision between products according to our objective. So if we agree on what we can measure and how much and what are the different indicators, the difficulty we have then is, can we trust the data we use to measure what we care about? Should we use generic data or specific data? Should we have national database or national adaptation of generic database? Generic database such as EcoInvent assumes simplified processes to model all human activities around the world. National database would be more accurate, but are not available and are really cost and time consuming to do. That's my personal idea, but I think that usually they also in fine usually rely on EcoInvent processes as background data. So they bring relatively minor fundamental improvements. Furthermore, and that's I think the key priority is not so much the location, it's also what is the level of detail. For instance, that's a study done by Alice Montcaster and her colleague, who showed the EPD, all the EPD of cement. And they show, okay, if you take an average cement, you have a wide variation. But if you start to have a certain high level of detail, if you take not the same one, but the same 142.5, 40, 52, then you have much lower variation. The same for SEM2. If you take all the SEM2, then you have a large variation. But then if you start to say it's a SEM2A, SEM2A, LL, SEM2A, M, etc., you have much smaller variation. So it is the level of detail of the data that makes its quality rather than fundamentally its location. You have less differences between two data assessing the same product in different location than two product types in the same cement plant. Other example is the comparison of concrete block producers in Brazil, where so it's a study from Van der Lejon and his team who have looked at 29 different concrete block, and they look at differences, and if you look at you see the variability mainly comes from the companies and not so much from the transport or the uncertainties on emission factors. You also see the median, and so it means that you have a majority of the concrete producers that are rather on the good side of the low side, let's say, of the environmental impact, while you have a few that are exploding the impact because they just don't make any effort for improving their production. So it means that if we want to have a specific database, it should really focus on one producer and not a specific product with a generic data on the average data of concrete block producers. So does accurate data actually really matters? That's a good question. And for designers, you need data to choose options in early design. So they need to be because it's in the early design that you really can take decision. But in the early design, you have a rough idea of the product. So you need to have aggregate data, which will show you the different potentials and maybe also allow you to visualize where you can take the most decision. So it's relatively simple data. The material producers, you need data, but they need to reward your good practice. So it has to be very specific to each producers and not an average of the practice. And it has then to be very simple to do for each practitioners. And so probably rather orient it towards a direct flow measurements than impact, like mass, carbon, water, and waste. So to conclude, LCA is a scientific work. It has to be used in construction for sure, but it has to be adapted to the specific stakeholder needs. Let's say for LCA for designers, it has to be simple and aggregated for early design decision. And then you need to have very few indicators on the product sheets for the final decisions, typically the 3 indicators that are doing in Swiss. Then for material producers, they need to reward their own factory and open practice. So it has to be very simple so that each producer can do it. And it has to be very transparent so that every consumer can trust it. And finally, you have LCA for system change, which help the policy implementation for systemic changes on circular economy, on decarbonization, on indoor health quality. These indicators, they have to be adapted to the policy objective and maybe diverge from the pure scientific assessment of what would be an environmental impact of the product. To give some example on further research, the LCA for designers, it is clearly now the field of parametric LCA or BIM-based LCA, where, for instance, Alexander Holberg, Benedict Kees, Aneta Naneva, or Bernadette Soesverdager are doing, and many others. The LCA for materials producers, this is the logic of a simplified LCA, which Van der Lejon and his team have really pushed that forward, and now it also starts to get some traction from the World Bank with the development of an edge tool, which is really based on simplified LCA. And finally, you have the LCA in system change. It means it needs to be implemented in the new regulation. And the interesting example is the recent French regulation, which have moved from thermal regulation for the energy efficiency of building during their operation to what is called now an environmental regulation, which take the carbon footprint of the construction and the operation of the building as a whole. So of course you drive very differently the construction, and what you would do is also that you need to adapt the indicators in order to really push towards decarbonization of the economy. So maybe to implement your carbon storage with bio-based materials. And with that, I would like to thank you for your attention, and I'm looking forward for your question.